Virtual reality pass-through uses external cameras on the front of a VR headset to show images of the real world to a user in VR. However, the pass-through camera captures a different perspective of the world than what the user would see without the headset. To account for this difference, computational methods can be used to synthesize the target view through image reprojection, but computational pass-through can lead to visual distortions, such as in this example taken with the Meta Quest 2 headset. Rather than rely on computational reprojection, we propose an alternative approach in which we design an optical architecture to directly sample the exact rays that would have gone into the eye. We call our technique light field pass-through. Let's start by considering a light field camera that consists of an array of lenses over a sensor. This isn't our final design, but it provides helpful context. Ideally, we'd like to measure the rays that would have gone into the eye, which we can approximate by choosing the pixel on the sensor that corresponds most closely to the ray bundle of interest. However, frequently we'd like to select a subset of the rays hitting one lens. Here, we'd like to select about half the rays from one lens and half the rays from its neighbor, but for each lens, it's all or nothing. Our key design insight is to add a set of apertures that physically block all the rays that shouldn't enter the eye. Here, we've highlighted the rays that reach the sensor, which you'll notice now cover only a fraction of each lens. Not only that, they're exactly the rays we wanted to measure. With carefully designed apertures, we can perfectly capture the target rays over the whole field of view. Here's an example of one of our lens array prototypes. If we designed the aperture array correctly, it will look like there's a single opening that exists somewhere behind the array, which you can see here. This virtual aperture represents the center of projection of the camera and is where we'll place the user's eye. When we put this array in front of a sensor, we capture raw data that looks like this, where each lens captures a subsection of the field of view. Then, to form our pass-through image, we simply rearrange the pixels based on an offline calibration and a coarse depth map, producing outputs like this. We demonstrate our light field pass-through architecture with a complete binocular prototype headset, where the user's eye is 35 millimeters behind the sensor. As you can see in this through the lens video, our headset operates in real time and the pass-through image matches what you'd see without the headset. Finally, this video taken with our pass-through prototype demonstrates the natural temporal consistency of our method. Compared to reprojection-based pass-through, such as this example taken with a modified Oculus Rift S, our approach has better image quality and fewer distortions around near objects like hands. Thanks for watching.